So in this video, we're going to assemble a Lego Tetrix robot using custom model pieces that we have imported into Robot Builder. This video is going to expand on some of the tips and tricks that we've learned in previous videos. And so to help get us started, I have set up my screen to have several of the windows docked to the side of it. You're going to find that life's going to be a lot easier if you do that. I've also have included the Tetrix assembly instructions, which is conveniently called Tetrix assembly instructions.pdf in your exercise files. And in a Windows 7 environment, I'm able to dock this instruction guide to the side of my screen like so. So you might find that that's helpful. Unfortunately, it appears that this feature is not available in previous versions of Windows, so you may have to print this document to be able to work along with me. So to start, let's address the issue of how do you go about importing in a custom model. In this particular case, these Tetrix components were brought in through SolidWorks in FBX format, and they were converted into a resource. So we're going to have to bring that resource file in. To import in custom models that have been turned into resource components, click on the Project menu, Add, and Copy of an existing item. Now in the exercise folder, I've included several resource files. We're going to be chiefly using Lego nxt.rres and the Pitsco components.rres. If you're interested in what this finished robot looks like, which we can take a peek at, you can click on Tetrix complete robot.rres, and that is a complete build of this particular robot. So let's start by choosing this particular resource file, so we'll see how it looks. And I'm going to go through this down here. So this is the name of the resource. We can bring in different types of resources, so resource files just happen to be one type of resource, but we could just as easily bring in custom scripts, textures, material files, even this narrative that I'm doing right now in wave format. So let's choose resource. It's going to ask me where in the Project Explorer I want to drop this resource file. So you'll recall from the previous movies that your Project Explorer is really just an organizational container for materials and model components that you bring in to Robot Builder. So I would recommend bringing this Tetrix robot into the resources folder because it is a resource file, but if you would prefer to place it somewhere else because you find that more convenient, you're welcome to do that. When I click the Add button, it takes a minute to bring the model in. And here, if you'll note, my Project Explorer has changed. My Tetrix complete robot.rres is in the resources. If I wanted to see what this finished robot looked like, just like any other object, I can take it and I can either drag it out onto the grid here. Oops, sometimes it takes a couple of tries. And it'll take a second for the engine to render it. There we go. And actually, looking back on it, it wasn't this resource file that I had to drag and drop into the grid. It was the sub-assembly called chassis. So if you're trying to follow along with me, and you're wondering what I did, that's what I did. Now, what happens is when we drag this object out in a three-dimensional space, it just sort of randomly places it out here on the grid. You may or may not find that to be a convenient option. I usually personally prefer to drag objects into hierarchy view because it allows us to establish parent-child relationships with other objects early on, and it will save us a bit of work down the road. So I can drag and drop this chassis into hierarchy view. Once again, it will tell me, well, in this particular case, again, error because the robot has the same name. So I will delete this robot. Delete. And I can just drag this back out in a hierarchy view. And again, I can achieve sort of a similar effect. So those are two ways to go about doing that. Let's delete this. And I'm going to bring in the component pieces, and we're going to build this from scratch. So I'm going to remove this Tetrix robot, hit delete on it, and whoops, Yeah, don't rename it. I got a little careless with the clicking. Oops. I right-clicked on top on this name here, and this menu comes up, so I will delete. Do I want to permanently delete it? Don't worry, it doesn't actually permanently delete the resource file on your disk. It just removes it from the Project Explorer. Let's go back into the Project Add menu here. Copy of existing item. This time we're going to only bring in the Lego Next and Pitsco components. So let's click Lego Next. Let's dump it inside our resource files, hit Add. I'm also going to go back into Project, Project Add, copy of existing item, and this time I'm going to select Pitsco components.res, and I'm going to add it. Now, depending on your computer and how many things you have going into it, this process may take a minute or two to go through. But when we're finished, what we should see is all the individual pieces that come in the Pitsco resource file. So for example, we can see things here like screws and gear head motors. I could drag this out and drop it. I can hit F if I can't find it and zoom in with my middle mouse scroll wheel. And I'm just going to turn off the physics render and rotate this, and we can see that this is actually just a simple component piece. So I'm going to delete this. Let's take a look at what's happening inside our instruction manual. So let's start with page 1 and work our way through this first phase. My first piece of advice is to set up a work plane. As you've noticed, the three-dimensional grid in Robot Builder is gray on black, and while that looks pretty cool, I find that with these smaller pieces that you can lose them very easily, and you can have a really hard time finding them later. So I typically will go into the Objects menu. If you don't have this menu on screen, you can find it under the View menu, under View Objects. And what I will do is I'll go down to the bottom where all my primitive shapes are, and I'll drag a plane out into my hierarchy view just so that I have a work surface that I can find. I will zoom. You may need to use a combination of the pan tool and the move object tool to get to the right perspective. I also typically with my plane will take a look at its coordinates just to find out where it is on this grid. So let's take a look at the properties for the plane. Let's give our plane first a meaningful name. I'm going to call it workspace. You'll note that when I click out of this, my name within the hierarchy view changes to workspace. If I click on the transform properties, that deals with the workspace or plane's position in three-dimensional space. You'll notice that Robot Builder placed it in an arbitrary location. I want this to be at the exact center of my model space. So I'm just going to choose 0, 0, 0. You'll notice that when I did that, my workspace disappeared from my view. So I can click on it in hierarchy view and hit F, and I've relocated it. So let's scroll up for a minute here and reorient my camera. Okay, so coming back to the instructions, we'll note here that I need one 288mm channel, two 2-inch standoff posts. I need 4 1/2-inch servo horn screws, and I need one 144mm angle. Now, generally speaking, what I find easiest is to take my largest objects, place them first, and then worry about the sub-assemblies such as screws and that later, and if need be, parent those sub-assemblies to the larger objects so that they're easier to locate. You'll see what I mean in a moment. Let's go into our Project Explorer and find the 288mm channel. So let's take a peek here under Channel, 288mm channel. I'm going to drag and drop this onto the workspace, and you can see that it appears. I also know that I need a 188mm angle, so I will find my angle, or 144mm rather, and I too will drag that onto my workspace. you'll note that because I've parented these two objects as children of the workspace, their default location is relative to the workspace. So that's another good reason for organizing your model in this kind of a relationship. Now if I get a little bit closer and I take a look at my instructions, we can see how this assembly has to start off, right? So the 144 millimeter angle has to be on the left, the 288 millimeter channel has to be on the right, and they need to be facing each other. Right now, as I look at my model space, I can see that it's clearly not the case. So let's try rotating the angle so that it is in the correct position. Now, the most tempting way to go about doing that is to click on my rotate object tool, click on the channel, and try and do it this way. And you may find that that may not work as well as you would hope. I'm going to undo this, come back to my default state, and I'm going to go into my properties window. I have my angle selected, click the transforms, and I'm going to enter in very precise coordinates. Now, generally speaking, you'll find that working in 90-degree increments is going to always guarantee that your model geometry is straight. So we will take a look at the rotation rather, expanded. And let's just try rotating this thing along its z-axis, which is my highlighted yellow axis, 90 degrees, and see what happens. Hit enter. Okay, so it rotated it. Part of it disappeared into the plane. I'm going to pull it up. So that's not quite right. Let's give it another spin. We'll spin it another 180 degrees and hit enter. Ah, that looks better. Let's now click on the channel and adjust its properties. So its rotation on the z-axis will, let's see what happens when we enter in 90. That looks right. And we'll try and position our objects. Now, this brings up actually an interesting dilemma. Right now, it looks like these two objects are fairly close together, wouldn't you say? But take a look at this. When I change my camera and go into an orthogonal view as opposed to a perspective view, look at what happens. The distance between these two objects was quite a bit different than I had initially perceived. Orthogonal view, perspective view. You'll find that in the case of modeling, it's much more convenient to work in an orthogonal view. And the reason for that is in an orthogonal view, scale is maintained. So no matter how far away I get from this, these two model pieces, or how close, their size relative to each other doesn't change. Whereas in a perspective view, as we discussed last video, it becomes very hard to tell the relationship between these two items the more we zoom out from our workspace. So most of the time you'll want to work in an orthogonal view. I'm going to make sure that these things are spaced. So I'm going to move this thing a little closer to the middle. If I take a peek at my instruction manual here, and I just take a quick look at the hole count here, I can see that these two components are connected what looks like 5 holes in, 1, 2, 3, 4, 5, and in the top hole. Now, keep in mind this is a beta version of Robot Builder, and going ahead into the future we will probably have the ability to have model snaps, but in the meantime you'll have to configure this manually, which can be a bit tedious, so you may not want to go hog wild with really over modeling the finer details such as tiny screws, just because it will take that much more longer to build your robot. The next thing we're going to do is, that looks like it's all centered up. I'm going to pull out my standoff posts, my two 2-inch standoff posts. So let's take a look at my Project Explorer. Let's go down here to the bottom under standoff 2-inch. And it really doesn't matter what object I parent these to as long as I pick one. So I think I will add one to the angle here. You'll note that if I pull this up, it this thing here needs to be rotated because it is parallel to the angle. So I'm going to take my angle, I'm just going to move it out a little bit so I have a workspace. I'm going to click on my standoff post. I know that that has to be rotated, and that the easiest and most convenient way to do that is to go into the properties and key in a very specific value for its rotation. So let's rotate this thing along its, what looks like its x-axis. I could be wrong about that, but let's just see what happens when I rotate it 90 degrees. Perfect. So again, let's try and line this up so that it touches the first hole. You may find as you're doing this that it's hard to judge depth and height and where you are, so if need be, remember your camera views here and rotate your view as needed. So right now I'm looking at this from a front perspective. I may find that it's a lot easier to look at this from the left. Here I can line it up. Let's just take a peek at where I am. Okay, so left wasn't right. Let's look at this from the right. This is a little better. So now when I move my object, I can line its hole up very precisely. And I can check it out from a bunch of different angles to make sure it's where I need it to be. So I might want it to be snug. Whoops. I might want it to be snug with the angle. And I will typically check this out from a bunch of different perspectives just to make sure that I have this right. So that looks reasonably good. Now that we've done that, let's take our second standoff pipe and attach it to the angle. So again, I'll go into my Project Explorer, I'll click this, and there's two ways of doing this. The first way is I could take this standoff pipe and add it to the angle by left clicking and dragging it over the angle, just like I did with the first. Another, perhaps more convenient way of doing this is just to copy and paste the existing standoff pipe, because if you think about it, it's already perfectly positioned. I just need to slide it down one dimension. So let's take this standoff pipe or standoff post, depending on how you want to call it, edit menu, copy it, and we'll paste it. Edit, paste. The pasted copy is in the exact same coordinates as the first, so we'll have to grab our move object tool and move it up. And again, I'm in a top front perspective, so I might want to go and take a look at this to see where it is. I'm just going to move it like so. When in doubt, I can always pan and angle the camera by using my right mouse wheel, mouse button rather, and using this pan camera tool, and that looks pretty good. The next order of business is to use the 4 1/2-inch servo horn screws and add them to each of both the angle and the channel rather. So if I look under S here, I can find this servo metal horn screw. That's the one I'm going to use. You could use any of these others. These aren't, exactly modeled to spec with what's in the manual, so for my purposes I'm going to use this. And I'm going to add it to one of my standoff posts. Click. If I click on my move object tool, I can see where it is. So again, I can pull it out. And because I copied it and pasted it right over the, or rather because I parented it to the standoff post, it's already lined up along its axis. In this case, it's y-axis perfectly, the standoff post. So if I zoom in, I can slide this right in. That looks really good. And again, because I did a reasonably good job of that, I'm going to do this one more time. I'm going to take this and I'm going to parent it to the other standoff post like so. I'm going to pull it back. And you can see how, at this point, how a more sophisticated model is made out of all of these sub-assemblies, right? So like a angle is comprised of these 2 standoff posts and their respective screws. I'm going to collapse this view for a second just because after a while it will get a little cluttered. And now what I want to do is I want to move my 144 millimeter angle as a whole component piece. You'll note when I use my move object tool and I pull on one of these directions, the whole model now is moving as one unit. And as you'll recall from earlier in this video, we know that this piece has to be lined up in the fifth hole, right? So I will count 1, 2, 3, 4, 5. That looks like I'm sort of there. I'm just going to change my perspective. Perhaps I'm going to take a look at what this thing looks like from the top. Might give us a better idea of where I need to be. Let's see what this thing looks like from the right. And for the coup de grace, I'm going to go now to the channel. I can hit F if I want to skip the effort of panning the camera. Whoops, zoom out, that got a little wild. And I'm going to add my half-inch servo horn screws to the 288 millimeter channel. So again, I'm going to come down here, and I'm just going to orient it myself to a view that I think will work for me. Take one of these screws, and let's dump it on the channel. Here we go. I'm going to rotate this. Let's take a peek at the direction here. So let's rotate this 90 degrees, or 180 degrees rather, along its y-axis. That might do the trick. And that didn't do anything that I wanted it to, so you'll see through trial and error that you just need to play around in here sometimes. After a while, you know, your perspective can get a little disoriented because you're always changing views. So I know that I'm 5 holes in, 1, 2, 3, 4, 5. I'm going to change my back view here. Now, something I've neglected to mention is that these views are relative to the object that is selected. So in this particular case, I have a servo horn screw. If I hit bottom right now, we're looking at this from the screw's bottom. If I go to the left, I'm looking at this from the perspective of the screws left. So keep that in mind when you're positioning these things. It will make life a lot easier if you get a grasp on that concept earlier on. Let's see what this thing looks like from the left. And let's see what it looks like from the front. We're quite a ways away. Oops. And I would suggest that the more you play with this, the much more proficient you're going to become with these tools. It took me a while to become comfortable using this. As I'd mentioned earlier, in future versions we're going to have object snaps, but the more you play with this, the more proficient you become with placing these items, the easier time you're going to have modeling, and the more productive you're going to be. So we're almost there. Let's look at this thing from a different perspective. Let's see what this thing looks like from a top perspective. That's not particularly useful. What does this thing look like from the left? Let's rotate this. Okay, there. That was a lot of work, but we did it. So I'm going to, now that I've established that that's in the right place, I'm going to copy this, edit copy, and I'm going to paste it onto the channel. and I'm going to add the very final screw. And there we go. There is the very first model piece of our Lego Tetrix as demonstrated here on page 1 of the manual. Now what I've done is I've included the first 6 pages of this manual and I've assembled it. So you're welcome to take a look at any of the other robot builder project files that I've included. And just to get a quick peek at what this thing looks like after the first phase of construction, I'm going to open up my model here. File open. And desktop. Page 6 completed. So this may be where this is in relation to everything else may be a little different for you, but I did save a build of the Tetrix after page 6, and I'm just going to open this up. And there's my Lego Tetrix. Now if I take a look, I've done a couple of things different. As this model becomes more complex, you may find it easier to remove the workspace because it will have outlived its purpose. Your model will be quite substantial, so you should be able to find it without the need for a plane underneath it, and the plane will just cloud your view. So I got rid of it. I created a dummy object, which to do that you click on an actor here, or rather environment, and add actor. And just to draw this point home, I'm going to call this dummy object, and I'm going to parent my chassis to the dummy object. So I created a dumb object called chassis just as an organizational construct. You'll see that if I expand this, I have it divided into a back channel, which is this bar. I'm looking at this thing right now from its backside. A front channel, which is this bar over here. If I can rotate this. I have a left channel, if I click on my movement tool. The plate underneath it, which is holding this assembly together, and the right channel. So try that out, play with it. Don't get too caught up in the minor details. What we really want to walk out with at the end of this exercise is just a functional prototype that we can use for testing. It doesn't need to be highly accurate, but if you're willing to invest the time and get good with positioning objects, you can build quite detailed models, as I have in this particular case.